This video is brought to you by Munro Associates.
From new product development to teardown benchmarking, Munro offers comprehensive solutions. We specialize in reducing costs and weight, drawing from 35 years of experience to help you maximize profitability and elevate your projects. Contact Munro Associates today, and let's turn your next project into a success story. Munro, innovation starts here.
Hey boys and girls, we're back again and we're here at, guess what, Aptera. So this is one of the cars that I've really been trying to follow for a long time, and if we look up, you can see that they're powered by the sun. Now, I know that everybody is worried about range anxiety and whatnot, but if you happen to be in San Diego or let's say south of the Mason-Dixon line, all of a sudden an Aptera sounds like a real good idea because in essence, you may get to the point where you don't even have to charge the car, ever. So we're here to look at the innovation and the progress, and maybe we even squeeze out a delivery date or two. So stay tuned, and this is going to be a lot of fun. Let's go. Okay, so I'm here with Steve and Chris, and I wanted to start out a little different. I mean, we've done these things before. You've heard me say a couple of things, and then we got right into the technology stuff and whatnot, but I would like to have Chris and Steve give a little background. You both got the same title, right?
Co-CEO.
CEO, yeah. Two CEOs, two chiefs. Where are the Indians? Anyhow, so I'd like to maybe kick it off. And Chris, why don't you start first?
Yeah, we started this program because Steve had a vision for efficient mobility. How do you use the least amount of energy per mile? And in his research, he found out that the first biggest hurdle is aerodynamics. Most of the vehicles on the road today use 60 to 70% of their fuel just pushing air out of their way. So if you're gonna make something aerodynamic, what does it look like? So he started doing great research in old aerodynamics books and then shared that knowledge with me, and we kind of came together on, okay, how do we put this in the computer and simulate it for the first time? And you know, that spawned kind of the initial vision for what is a super aerodynamic vehicle. But then, you know, you also have to focus on weight and the efficiency of the powertrain, and you know, now adding solar power to the mix has really kind of tied a bow on everything that we've been doing the last decade.
Yeah, I think when we first looked at putting solar on the roof, and we did some calculations with the new cells that we got from Axion, it was such a significant number. Like, we were both looking at the number and thinking, and we almost said it like at the same time, it's like, why don't we just cover the whole vehicle with them?
Yeah.
Because then we'd have enough to drive 30, 40 miles, you know, or 10 or 20 miles, something like, we didn't know it'd be 40 miles. So it's really that leap that we made together. Once we saw how efficient it was and how much the solar could do, we said, let's just cover the whole damn thing in solar cells. So that's what we did.
What I want to jump into now is let's have a look at some of the technology, and the most obvious is how this is popping here. You can see the cells. Now, you don't have them this way now. We're going to see this is the alpha. We're going to see the beta in a second. Or is that gamma?
Gamma.
That's gamma.
Beta's still in Italy.
Yeah. So at the end of the day, you can see these ones. Those ones are a little tough to see. So why don't we talk a little bit about the cells themselves and how much extra you're actually doing. I guess the word's out about the airport stuff. So I think you can you talk about that?
Yeah. I just can't mention the airline, but I can certainly talk about the project.
Oh, okay. I could. It's on the internet. I mean, it's all, once it's in public domain, it doesn't matter. Yeah. So anyway.
Well, I mean, you see the writing on the wall, literally, when you walk in, every journey powered by the sun. That dictates everything that we do. It sets our vision for new products. It always makes us chase efficiency, whether it's, you know, drag or lightweight. And it started with the alphas. The full working solar on Gamma is something that we can even see today on a cloudy day. We'll go outside and look at how much power we're generating. But as you alluded to, we have also been looking at other industries where we could not just add solar, but really move the needle, like radically change their application. And that's what we're able to do with the airline. We've taken it from having to plug it in every several days to never having to plug it in at all. And when you're deploying new electric vehicles across an airport, because there's a major shift to electric with all the ground equipment, one of the big problems that comes up is the chargers, where to install them, the lead time, the cost. You can't drive a big tug all the way across the airport to charge it. It needs to charge where it is. It's not designed to drive that far. So solar really solves a lot of problems in that industry, and we're excited about that space.
Well, I think that that airports are a wonderful place to start, but at the end of the day, I think that there's a ton of other applications that that your solar system should be able to solve. So.
Absolutely. We've got a working list internally for the folks doing business development. I don't want to disclose it to the world, but there's certainly lots of opportunity. So I don't know if you've ever seen this in motion, Sandy, but with your team, we developed all the different assembly stations, and of course we had this animated to show what it looks like. But this is all really the result of your team and our team working together to determine what happens at each build station.
Yeah, so this from our team anyways is all Tim Shaw. There was other people that came, but Tim Shaw was the lead on this stuff.
Now some of this will probably change if we're depending upon what we're doing in Italy versus what we're doing here.
Well, yeah, because isn't a lot of it's going to be manufactured in Italy and shipped over, right? Yeah.
Yeah, if the Bink comes as a roller, it'll be very similar to this. But if the Bink just comes separate, then we'll have to add some suspension.
Right now we have the whole body dropping in as one piece.
Yeah.
But everything starts with the battery packs. It's the heaviest part.
Yeah.
12 stations, 12-minute tack time. So in an 8-hour shift, you can build 40 Aptera.
Yeah.
And in this facility, we can run 2 shifts, so we can build 80 Aptera a day, which is about 20,000 vehicles a year.
Well, let's show some of the differences of gamma. We were just looking at appliques or painted on, or solar cells just applied to the surface over there. These are functioning cells, and this is a glass panel. It's very thin, but it's flexible. And the biggest part rather, of our intellectual property is how are we able to bend these solar cells without cracking or without introducing micro cracking. And it's a micro cracking that degrades a solar cell with vibration or damage or that kind of thing.
Yeah.
And you'll get it from just bending it, but we don't get it when we bend it with our process. And that's a big part of our patent portfolio. Plus the polymer stacks required not only for encapsulation, water barrier, and toughness, but without adding a lot of weight. So you end up with an extremely light solar panel that's rugged and ready for automotive use, and all the travails that come with automotive use, rocks and chips and that kind of thing.
Yeah.
And the top coating is actually glass, so it looks like a polymer. You would think it's a polymer because it's so thin, but it's not. It's glass. It's got extreme toughness, scratch resistance, and it's got obviously a nice luster like a windshield.
Is this Gorilla glass?
I mean, it's strengthened, so it's. But it's not Gorilla Glass.
So we've actually been using gamma as a little bit of rolling test bed of different solar technologies. So we have glass and then we have polymer panels. You can see the surface finish on the polymer panels is not as smooth, right?
Yeah.
You've got the turtling effect.
Yeah.
This is why we're not using polymer in production. We're using glass in production.
Yeah.
But we were able to see that, we do eventually, once we're able to spend resources on it, we'd love to productionize a polymer because it would be a cheaper, lighter weight panel in the end. But right now it takes too much work to get it automotive grade, so we're just sticking with the lightweight glass for now. And we'll pick up a panel of the hood panel over there shortly, just so you can see how light it is.
But the big difference between the Alpha and this one was mostly that we increased the interior size. So we aerodynamically, we lengthened the vehicle 4 inches, so it had slipped through the air a little better. We increased the headroom, lowered the seats some, pushed the belly out a little so we could make more room for batteries. So it is a little different architecture, pushing and pulling, because when we built that one, we only had what was in the tube to go by, what was in CAD.
Yeah.
And then we just had to build it and use it. We couldn't be like a big automotive firm where you'd build like an interior buck and have 100 people sit in it and see how it feels.
Yeah.
We just had to build it. So a lot of little changes in ergonomics, packaging space.
Have you been in gamma before or seen it when you were here last time?
No, I didn't see it. I didn't get in it either. So, again, I'm a big fan of yokes. As they say, Sandy, the yoke's on you. But anyways, I like this type of an arrangement. This is very familiar, and you've got a little dashboard up in front that helps out. Let me.
Oh, yeah, I don't think that's probably not much adjustment.
Yeah, it's good enough for me.
So when the doors are down, Sandy, you'll see your side view. I'm going to close this door here.
Yeah, okay. Yeah, so I'm a big fan of cameras. I really don't care much for mirrors. They are mostly useless, and they've got too many blind spots. But the EPA, or sorry, not the EPA, NHTSA doesn't want to.
If you could write a letter to somebody.
I've written lots of letters, and they immediately either burn them, put them into the shredder, or throw them out in the garbage. So
We know how you feel. We had to start an online petition to get the North American charging standard for the Aptera. So
well, that's there's a lot of reasons for that. We don't want to get into politics. Grace wants me to be a good boy. So how do I
push
get
that
out
button
now?
if you want to open the door.
This button. There we go. Yeah, I didn't push hard enough.
So it's about I don't know how many gallons that is, 1,000 liters? 1,000 liters of storage? It's a lot. Ladders, skis, spears, if you're into that kind of thing, you name
Spears.
it.
Well, I know I can get at least 24 shotguns in there. I don't know about a deer carcass, though.
Definitely a deer carcass. Unless it's a huge
I know,
deer.
but I don't know.
Plastic.
Oh, maybe I could. Yeah, that could work.
If you push the seat forward, you have
so.
7 feet from the back of the seat to the tail. So you could fit a couple surfboards, you could fit a couple mountain bikes, and we actually have a tent that goes over the side so you can actually camp in the back. And I don't know if you saw the design changes, but in the production version, we extend the hatch so it actually closes over the rear.
Oh, cool.
So when you get in and out, or your pet gets in and out, or you put construction equipment in and out, you don't have to worry about
jump
scratching
over that. Yeah,
anything. I've
that's
got
a real good
the
idea.
supercharger access,
Woohoo! I love that.
so we can.
That's a really good idea. So you're using a motorcycle license, and which you are a motorcycle. You're that's.
Part of the changes in this from the Alpha was that we had this plate and then we had another inch or so on either side. The artificial intelligent generative design said, hey, if you squish the tail another inch on the back, then you could get a couple more points of efficiency aerodynamically. So
wow.
The tail used to be here, we stretched it to here, and we smushed it down some so we could get closer to the license plate. But
Oh, I love the application of the license. That used to be real popular for old-fashioned gas cars.
Right, that's how you
shove
fill
in
them
there.
up. You usually flip it down, spring-loaded.
Yeah, it was either down or up.
Yeah.
Usually, I think if you brought it up, they had a little kickstand, and when you brought it down, in a lot of cases, they didn't put a gas cap on it because the back of the license plate holder had a rubber thing.
Yeah.
And
Oh,
plunk,
interesting.
And that was it. Yeah.
part of the regulations were that you had to be able to charge it and see the license plate, I guess, if they want to give you like a parking ticket or something.
Ah, I see.
But you always had to see. So flipping down didn't work because you couldn't see the license
No,
plate.
I
when
love
it was
that.
charging.
It looks. I like that a lot.
But
That
it's
looks real cool.
it's not mechanical, so you don't have anything to break. It's just magnetic, so you just pull it.
Yeah.
Super simple.
Okay, so this is what we call the body in black. This is all of the structural stuff that you need in order to make a car. These actually, there's only a couple of pieces here, but these are all made in one fell swoop. They just come down. This is SMC, sheet molded compound, and it comes down and it comes back up, and for the most part, you've got a finished product. One push. All done. But this one here, this may have more, I'm not sure, but what I'm looking at here is amazing, an amazing amount of construction, and it's all in one gigantic piece.
The largest carbon fiber SMC part in the world.
And there you go. So
And you end up with something that looks like an injection molded part. You
Yeah.
get these facets to hold wires and wire tracks,
Yeah.
and you have embedded fasteners. And
Yeah.
the cool thing about how the parts relate to each other is they all key together.
yeah.
So you know you've got keys that bring the parts together like Legos.
Yeah.
So you don't need these huge fancy alignment robotics, or laser alignment anything. They just go together.
Well, you don't need 2x4s and sledgehammers to make it fit either. So that's kind of like one of the things I like about carbon fiber. And for those who've watched what happened when we took apart the BMW i3, which was also carbon fiber, that was the one thing I said. Every car build is perfect, and it'll stay that way forever, because this is a stone. This doesn't move anymore. Once you set it, it's done. It's not like sheet metal that expands and contracts. It's not like anything that any other material. Carbon fiber is there forever, and that's why all aircraft have moved toward carbon fiber. Nobody in the world would dream of trying to go backwards in time, because this is the ultimate as far as strength, rigidity, accuracy, on and on and on. It's got it all. Carbon fiber is the best. And by the way, we mentioned CPC, but we didn't mention was that they've been purchased by
Mitsubishi.
By Mitsubishi. Mitsubishi Chemical has just bought them, and that just means that if there's money involved, you usually find a Japanese company saying, "Oh, that sounds like a good idea." Like I say, all of the major fancy cars are made this way now, and you guys making it here is, I just think is brilliant. This is way more than I expected you guys were going to, get into, but I'm super happy.
Mitsubishi material in every Aptera, just like you would find in some of the world's highest class supercars.
Yep.
We're built for efficiency. They're built for speed.
And lightness, because okay, pushing air out of the way is one thing, but weight is always going to be a problem. The more weight you've got, the less efficiency that the car is going to have, and this is super light in comparison.
I've been losing weight, but I actually weigh more than the whole body structure of the Aptera.
You weigh what?
More than the whole body structure of the Aptera.
So just out of curiosity,
about 200 pounds for the whole body structure of the Aptera.
200 pounds.
Mm-hmm.
So this is lighter than the BMW i3.
Oh yeah.
And quite a bit lighter, because this doesn't have a frame to go along with it.
Well, we have the chassis that supports the battery pack and suspension and all that, but just the main body structure.
Okay, so the main body structure on the BMW i3 was in excess of, I have to go from 300 pounds, somewhere around 300 pounds. So this is 100 pounds lighter.
Well, they used a
than
lot
the
of mixed
BMW i3.
materials, and they were using that fiber forge oriented strand
yeah, but they
stuff.
also had aluminum parts for cross car beams. They did, and it was all hand laid up, or not hand lay up, but it was a laid up product.
Yeah, we do have a lot of metal parts that are not shown here. You can see over there. We have a roll cage, the door beams, cross car beam, all those. It forms sort of a metal or steel circuit around the occupants, and of course the frame, the chassis and frame underneath. But I think the carbon structure, is pretty lightweight. In fact, we could probably, the three of us could pick that one up over there. So. And that one is made without any of the metal reinforcements, because that's a wiring buck.
Well, as long as, if it's 200 pounds or less than 200 pounds, two of us should easily, most people can lift up 100 pounds. But this is, regardless of how much all the weight in one it is, this is just fabulous. And it's, like I say, lighter than the BMW i3. And it's about the
lightness
same
helps
light.
us in manufacturing too. That you can human position all the parts.
Exactly.
So if they get too heavy, now you've got to have robotic assist or lift assist. And, this part being 25 pounds or so, this part you can actually have one or two people actually position everything, which makes scaling a lot easier. You don't have to over roboticize and stuff, right?
Yeah. Well, at 200 pounds, that's a different thing, but. For all the other parts that are going together, if it's less than 40 pounds, a human can do it all day long. Or you can buy Tesla robots at 80,000 a piece, and there you go. So let's move on to this.
The body sides, left and right. Once these pieces, again, they sort of key together internally before they're bonded. And then this whole piece is just bonded to the side of the vehicle.
So is this white carbon fiber?
No, that's fiberglass.
Yeah, that's what it. Yeah.
So the less structural elements.
Yeah.
So this part back here is more of just an aero shell.
Yeah.
So we use a thinner and lighter weight material, cheaper.
Yeah.
And then we use carbon where we really need the strength.
Yeah.
This is about 6 times the cost of this. So.
Yeah, but it's also about 100 times stronger than that.
Yeah.
So. Yeah, so great stuff. And then right in back we have a door. So all we have to do is walk around here.
This is so pretty. You guys have done so many videos on different teardowns of different door structures, and we're pretty proud that your team helped us design this the way it got designed.
So we've got locations for the regulator, the motor, all the stuff that bolts in it. This particular one does not have it, but they will come with the threaded inserts from the tool. So they put those in when they press apart.
Well, the other thing is you can buy onsets, which I kind of like as well. Because putting things in tools, people get in the way sometimes. But if you use the onsets, again, a robot can pop them in, and they're dead accurate as well. They're glued on, and when we were testing those, we were hitting with like a 5-pound hand sledge, and we would either break the stud or we would tear the carbon fiber before we could break the adhesive.
Is that the UV cured ones?
Yeah.
Yeah, okay.
Yeah.
They use those on the BMW a lot.
Yeah. Anyway, see how I can put my finger in here and it kind of gets tight all the way along? That's because with sheet molded compound, I can get a straight, I don't have to have a draft angle. These are things that you get for free when you're using sheet molded compound. And again, I go back to the guys that are making them. Who made are you allowed to talk about the moldings, the molds?
Oh yes, Energy, the company Energy, also in Italy.
Yeah. So Energy, and there's another one called CoStamp. These guys are brilliant at this. Tragically, I don't know anybody in the U.S. doing this. So if you do, if you are in the U.S. and you can make this kind of mold, let me know. So I'm really excited about this. I'd heard about it. We have briefings and whatnot, but this is my first chance to see it.
Just look at the A surface. So this material, when it comes out of the mold, it's basically ready for wrap.
Yeah.
It doesn't have to be sanded or treated or anything.
Yeah.
It's ready to have the wrap
Well,
installed.
you don't have to ablate it? There's nothing?
No.
Really?
We did a bunch of tests where we tried different methods, and none of them seemed to work better than just putting a wrap on it right after it came out of the mold.
Cool. Excellent.
So this is the underside that you will see in the vehicle, and then the solar panel will be bonded to the top here, and that's the complete rear hatch. So it's not an inner and outer clamshell. It's just, this is the rear hatch. We add our solar, and it's done.
Wow.
Up there goes your reverse light and your camera system.
We don't call it a chimsel, right?
No.
Center high molded, whatever. Anyway, is this trough right here, is this for wiring then, or?
Nope.
What
It's
is?
just to give it a little extra structure and rigidity.
So it's a down flange.
Yeah.
Huh. And this is like, really light. How much is this? This got to be like, this is like
10 pounds maybe?
I know one thing for sure, it's less than 40 pounds. Wow, that's...
Surely a third of the weight of any typical rear hatch. That's probably half this size, right?
Well, rear hatches usually have a big chunk of glass in it, which just precludes anybody being able to pick it up. So this is, this is...
But again, because it's a stone, once it's set, it's easy to align. It doesn't move around on you a lot. We're not using
well, if you drop it, you don't
sledgehammers.
bend it.
Yeah.
That's another thing that happens with a lot of steel parts and whatnot. They're not quite put together yet. They're in racks. You get somebody who's had a bad afternoon or getting tired or drunk, and the next thing you know, they try and pick something up. They're pulling it over, bang! It hits the ground, and you have scrap. This bounces. This will hit the ground and laugh at you. So.
So this jigs up our roll structure. So this is what's underneath the composites. This connects our roll hoop down the A pillar all the way to the crosscar beam for the dash. But very simple sheet steel, really lightweight. So it doesn't add a lot of extra kilograms, but it adds that stiffness for the roof crush strength. So the carbon fiber does move on you a bit, but as soon as it hits this stiff member, it'll give us really high roof crush numbers.
Yeah. And here we have the structural member that keeps everything where it's supposed to be. This looks 100% fully machined.
It is. We're out seeking funding for the high volume production tools for this, which is U.S. Capital's helping us raise a convertible note now to pay for the dies for big parts like this. But it was easy to get it milled for the first parts, and this works for our validation, calibration, and initial testing. So these parts came in last month, and the teams built the jigs for them, and now these are all positioned, obviously, in the first production intent build. It's already welded together, but this still has to be welded together, and it has some inserts for some screws and stuff. But
wow. I doubt very much if you're going to buy your own machines. In fact, I would highly recommend you don't. Not for that kind of production rate. Not till you get to over 50,000 a year.
yeah, we're deciding what we want to do for the next 50 vehicles. So, you know, do we want to build
machine
low
it.
volume production tools? Do we want to sand cast, or do we just want to machine it?
Sand cast is not strong enough, but you could, if you wanted to, 50 vehicles is not very many. You could probably 3D print this thing. You'd have to go up it. You'd have to bounce it up a bit, and probably go to titanium or something. But
The monster's this bit because it's so it's so big. So.
that thing is like that's like what you see in aircraft a lot. They take billets and machine them down like that, and that's kind of time-consuming and expensive because the machine that you're putting that on is going to be super duper expensive. But if you decide to go into high production or higher production, these three pieces should be one piece. And I would highly recommend that you look at high pressure die casting.
Oh baby, look at how aerodynamic and lightweight this is.
Baby, that's what I like.
It's like a tuning fork for the gods.
Yeah. Wow.
But obviously focused on you know, as little aero loss through the suspension as possible. The lower arm's a little more tricky than the upper arm because it's longer. But these will be die cast too, eventually.
And then maybe Jason could explain the wheel pant mount.
Yeah.
So this is what the wheel pant mounts on. The hub mounts on this, the hub, and the wheel pant mounts on this. So it's a much lighter, stronger structure than how we were doing it before.
Also really rigid, so it holds the wheel pant on really nicely.
Yeah.
It's our own custom rotor, but the caliper is off the shelf from Continental.
Wish the rotor could be lighter weight. So.
Holy moly, that is heavy. Holy doodle.
So lots of opportunity for weight reduction on the rotor for sure.
Especially when you're getting most of your braking from regen anyways, right?
Exactly. But engineers don't believe that. They have to be shown it. These drive shafts actually, they had to be modified for our use, but the vendor GKN is our chosen vendor for production.
And then this is that cool trailing link rear suspension. So it floats much more predictably like a four-wheeled vehicle. It doesn't feel like a three-wheeled vehicle or something quirky like some of the other three-wheelers.
Like a motorcycle. A motorcycle will arc its rear wheel, but this goes up and down. It keeps it straight, keeps the center line straight, so and it improves the handling.
But all this goes on this beautiful build that we can talk about now if you want to. This is that beautiful chassis mounted to our beautiful bink.
Start at the bottom and work up. So here's what we were just looking at. This is the frame we were looking at. Here you can see the carbon fiber body, and you can see that there's some massive bolts holding this together. And you've got. So what?
That's just a runner that holds the belly pan on. So it's
right.
lightweight runner to hold all that. That rear piece back there is what holds the rear wheel skirt on.
Here we get a chance to see the
Looks prettier in the light, huh?
yeah. Yeah, so that's why I'm being quiet, because this is my first time seeing this.
We're exciting all of Sandy's senses here. This is
Yeah.
like ASMR for carbon fiber and aluminum goodness.
So there's still some opportunities here for
Oh, yeah.
maybe getting rid of cost, but after you get the production intent builds come, then maybe we should talk some more. Find out what the guys have to say about how the build went and stuff.
We're not
And,
done. This is just the beginning. Get the first 10,000 Aptera on the road, and then
Yeah.
sky's the limit.
There's already a booklet of notes from just building the first one that we have already.
Yeah. Well, usually, the punch list they used to call it, and I'm sure that you're going to move from notebooks to supercomputers, because everybody's going to find something that a little something that could bring a little something to the bottom line, and basically you've got the big dollars taken care of. Now you start looking for the nickels, the dimes, and the pennies, and that's the second or third scrubbing.
The big reveal here, Sandy, is that there were no surprises. You know, people say, well, it looks just like the CAD.
Yeah.
And it goes together just like it does in the CAD and the animation.
Yeah.
So that was really, there was no effort necessary to figure out anything. Everything just kind of went together like we thought.
Well, and that doesn't happen very often when you've got prototype builds or production intent builds, and the reason for that is because normally you're screwing around with stampings that kinda went together. And that's where hammers and 2x4s come in real handy.
This is a track vehicle. That's its intention. So it's set
Yeah.
up for a 5-point harness, which is why I've got the bars there for the harness stuff.
I was just going to ask about that
Yeah.
bar right there.
That's
Yeah.
just for the harness. That's not production. That's just added for this vehicle.
So what track or what are you going to take it on?
Powertrain and battery testing. Immediately to begin getting some numbers.
Yeah.
We've got privileges at an OEM track out in Arizona, and so we look forward to doing some development work there.
Cool. Excellent. Wow.
Why don't you
It looks brilliant. I mean it.
maybe give the door a close and see what you think. These are the new struts, so it's going to be a little tight, but we can close it. Did it latch?
I don't know. There you go.
There it is. So this is over that. So
It doesn't have any seal pressure on it. So I
that's
think,
what it is. Okay. All right. Great. So that side also will be a
And this you don't see until you have the solar panel on it. So
Yeah.
the solar panel sits a little proud, but
yeah. The gap is perfect. I mean, it's exactly from top to bottom here. I already ran my finger through here, but this is just fine. This is the
Also the
fixed
upper
glass
window.
for the upper part of the door, and this will be the glass for the regulator for the window. Yeah.
this was a bit tricky because it's got kind of that helicoil.
Yeah, it's
Shape
kind
to
of
it.
like, I'm looking at it, it goes in a really,
We talked to a lot of different manufacturers
Banana.
that said, no, we don't like it.
well, not everybody likes everything.
And this has a good amount of a side curve that people
Contour,
aren't used to. So we had to find a sophisticated manufacturer to get that curve on the edge. The curve along the full axis is pretty easy, but this extra bit of curve here was a challenge for sure.
Well, as long as you don't start bending it around into a 90, you should be able to get anything you want with glass.
Yeah, we test fit it last week. Looks great, fits great.
Perfect. So,
Let's see if the
well, we're gonna do this. Where's my, oh, there she is. Okay, good.
lighter weight component.
And I love this little hole for hanging on to.
That's exactly
That's
what it's
perfect, yeah. I don't want to kick anything that could be very valuable. So you've got a different steering wheel in here.
And we will have a yoke, but now for this one we do have a wheel.
So is that because it's going to be
Because the
test track.
first steering wheels are super expensive to tool, so put the cheaper steering wheel in the test car.
Good idea.
That way you
Wow,
don't get it
plenty
all
of
dirty
room.
for when we first do shows too.
Yeah, there's a lot of room in here.
Yeah, but hopefully you feel a good amount of headroom and you
Yeah.
know, a bit more spacious, and the rear view camera goes in that center bucket there, so it doesn't hang down like
Oh.
a traditional mirror anymore.
Cool.
So it's keeps the forward visibility nice and open.
Yeah. That feels very comfortable.
Want to close the door?
Let me see if I can actually do it myself without.
It's got extra strength on it because it doesn't have the glass
Yeah.
and stuff in it.
There we go. Yeah, the foam in here is going to make a difference as well. When you put the foam in.
And then the mechanical releases down there by your foot, by your
I see it.
by your
This
shin.
one here, yeah. Right here. So you've got a mechanical override, but it'll be electric.
Electrically actuated,
No,
yeah.
yeah.
And it'll be a touch button on the screen and a button on the door. So you could open up your passenger's door from the screen.
Oh, that's a good idea.
Not
So what
that
am
you would
I
ever
looking
want.
at over here? Normally what I'd see for this would be something I'm going to switch on for maybe Knox or something like that. And so what are we
No,
what are we looking at?
So this is a track car. It'll never have a full interior. It may not even have the IP installed, just a cross-car beam.
Yeah.
So it's very bare bones. It just has a switch for coolant pump, fan, some other things like that.
Okay. So how much are you looking to raise? I'm assuming you're going to get another round. So what are you looking to raise on this round?
We're currently raising a $60 million convertible note with U.S. Capital, and that's enough to buy the production tooling and equipment and finish some ED&T, like for the airbags and ABS,
Yeah.
to get the initial vehicles into production. That would hopefully ship vehicles late next year, and then get us to a run rate of around 6,000 vehicles a year really quickly, which is cash flow neutral for us. We think along the way we may open up the crowdfunding again, because right now the minimum investment for the convertible note is 50 grand. So a lot of people have been waiting to invest in Aptera, but they can't because the minimum's so high. So
Yeah.
but it's going well. We've made lots of great connections over the last 2 months, and hopefully we'll continue the raise and be able to start buying some of this bigger equipment, like the castings for the rear and stuff like that soon.
So any any big Chinese companies sniffing around yet? Or
Yeah, we've had offers for years now from different companies, but we want to maintain control of the company. Our mission here is to deliver as many Aptera as possible in the next decade. We'd love to deliver 1 million Aptera by 2033. So, we want somebody that's a real enabler. So we're fine with strategic investment talk. We just want somebody that will really enable us to build more Aptera more quickly, and build it in the virtuous way that we want to build it,
Yeah.
for efficiency's sake, for for reasonable cost, for all the things that we've espoused over the last few years.
Oh, Steve and Chris, this has been brilliant. I'm really, really happy that we got the chance to come down here and have a look at everything. I'm really impressed with the progress that you've made. I know that there's going to be bumps in the road and stuff like that, but looking at what you've done with basically a paltry amount of money. By the way, we didn't talk about it, but to get to this phase in a conventional car company would be, you'd have spent by now somewhere around $500 or $600 million to get to where you are. So how much did you spend on this thing so far?
Pennies of that.
Pennies of that.
100 million.
100 million. So basically 6 to 1, basically, because the more I think about it, the more I'm thinking more like 600,000. And here you are, and I'm just so impressed. And this is a perfect build. The carbon fiber and everything else that you've shown us is telling me that this car is, when you turn the switch, product is going to come out the door. It's not going to be some of the other vehicles that people have pumped billions of dollars into and got snake eyes in return. So I'm really impressed. Great job.
Well, we appreciate
Thank you
your
so
support
much.
along the way.
Thank
Thank
you.
you.
Thank you,
Thank
sir.
you, and thank you for watching.